Hi everyone, welcome to this new lecture of fluid mechanics. In this lecture, we'll discuss the concept of flow measuring devices. So in our previous videos, also we have discussed the flow measuring devices uh, during that venturimeter, orifice meter, and pitot tube. Okay, so there also we have discussed the flow measuring devices. So apart from that orifice meter, venturimeter, and pitot tube, few other names are there, or few other devices are there which is used to measure the flow or rate of flow. So few names are there. Let me highlight this. So one is flow meter, one is flow meter, or we can used to call it as a nozzle, flow nozzle, or it is also called as nozzle meter. It is also called as nozzle meter. Okay, and the next one is similarly another one is there, that is rotameter. This is rotameter. And the next one is, we have another one devices is there, that is flow meter, that is flow meter, or we used to call it as elbow meter, or we used to call it as pipe bend meter. Anything you can call that one. Pipe bend meter. So this lecture will discuss only about the first one, that is flow nozzle or nozzle meter. So let me give a first heading that one. So first one will discuss about nozzle meter. All these measuring devices are different diagrams are there. So we'll see one by one with the diagram, and we'll see what are the working principles are there, and what are the applications are there for this, and what are the advantages and disadvantages are there. So all the things we'll see. Okay, so let me draw a diagram for this actually. So suppose there is a pipeline is there, and through the pipeline we have some water flows there, and in this pipeline let me connect some pressure measuring devices, pressure gauge. Okay, and this one we can draw like this straight, and here I'll keep some pressure gauge type, okay, to measure the pressure at this particular point. And similarly again, just to extend this, and here also another one pressure measuring devices or pressure gauge. You can continue like this. Okay, so we'll have can draw like this. The pipe should be different, opposite should be there like this. That means, okay, like this we can keep it. Yeah, now here if you see, there is a liquid flow is there, or water flow is there, or any kind of fluid can be flows in this. So there is a flow is there. Okay, now here, as I told you, this is the pressure gauge to measure the pressure. So suppose here P1 is there, at this side P2 is there. So this is normal pipe, and there is a fluid flow in this pipe is there. So what about this flow nozzle or nozzle meter, where it is? Now here we need to fit a nozzle meter with some nut and bolt and all these things. We need to keep it at this point. So you can fit one nut and bolt. Now the question is, to whom will fit the nut and bolt? Now here we'll take some couplings, okay, and we'll feed that couplings here, and through this we need to enter the nozzle meter. So nozzle meter is like this. Okay, so here also it will come like this. Okay, so the device is like this. Okay, then this device is fixed on the coupling and with the help of nut. Okay, and these are the studs are there. These are the stud and nut and some couplings are there, and this is the pressure gauge. Okay, so here there is a liquid is flowing here. Now at this region, if you see, the diameter of this total will be, we can consider, suppose this is the diameter, full diameter is there, so d1. And now when the liquid is coming and flowing like this, because there is a nozzle type meter is there, so this concept is called actually nozzle meter. That means we know that nozzle why used to use to increase the velocity of the fluid, and that shape of this nozzle is to like it is to like this. And we have seen also previously, we have discussed also, so it used to fit on the at the tip of the pipe, okay, to increase the flow velocity, so that the water which is to come out from this tip, okay, with a high velocity is to come out. We know that one. So here the concept also similar to that. Okay, so the water which is coming out through this, okay, all this energy which is to present in the water, so that is going to be converted into kinetic energy here. So the water which is coming out, you can draw like this. Okay, normally it will come like this. Now if you can see, this region is there, this region and this region we have vacant, like vacancy is there in this region. That means there is no liquid flowing out this region. So here there will be a vortex will be created here, this region. Okay, or you can say that kind of spiral time or some vortex will be created due to this flow or due to these changes of liquid in this region and that region. Anyway, so that is separate issue, is separate regions are there. Now this is the diagram of a nozzle meter as I have shown you. Okay, now what is the work of this and how it is going to work? So as I told you, this nozzle meter, so this is actually used, this is used to measure the, discharge through the pipe, discharge through the pipe, because we know that the measuring devices which is used, or we need to find out the rate of flow, already I have discussed the rate of flow or discharge. These things already we have discussed in our previous lecture. Okay, so here also this nozzle meter, what is used here, so that is going to be used to measure the rate of flow or discharge, as I have written here through this. So what it consists, or what this device is, what it consists, this device is consist of a nozzle, through which the liquid is flowing. This is one point. Okay, and if you see, this is the nozzle part, and here this part is also is called as throat part. Okay, and this is the tip of this nozzle. Okay, and the fluid which is flowing through the nozzle, if you see the fluid which is flowing through the nozzle, the velocity of the fluid, okay, as I told you, it is going to be increased. Okay, the velocity of the fluid is going to be increased, okay, of this nozzle. And because the area is reduced, okay, the area is reduced, so the velocity is going to be increased. So this is based on the continuity equation. Already we have discussed regarding the continuity equation, that is nothing but A1 V1 equal to A2 V2 or AV equal to constant. So area is dependent on the velocity dependent on the area. So now here area is reduced, so the velocity is going to be increased here. That is one concept. This is based on the continuity equation. I hope you understand. Okay, next part, one more point I'll tell you. So the next thing is for this horizontal pipe, if you see, this is the horizontal pipe we have considered here. So here the velocity will be increased, or it is increases when then the pressure is going to be decreased. If the velocity is going to increase, then the pressure is going to be decrease. So this is based on what? This is based on the Bernoulli's equation. This also Bernoulli's equation also we have discussed in the previous our videos. You can refer that one. So continuity equation, as I told you, here also same thing. P1 by rho g plus v square by 2g plus z1 equal to constant. So that is Bernoulli's equation. And at the throat, if you see this throat part, Okay, this throat part if you see, and it's like a venturimeter. The throat part is like a venturimeter. Now, if you remember the venturimeter video, there you can also see how this venturimeter device is there, how it is working. So here also the throat part, if you see, it is like a venturimeter. Okay, because see, I'll just remind you that venturimeter, as I told you. So venturimeter concept is like this. This is the converging part, then throat part used to come, then again it is going to be diverged. This is the diagram of venturimeter. For your remembering, I'm just showing this diagram. So if you see, the same throat part is here, that venturimeter. So there is no conversion portion here. There is no conversion portion, but here if you see, the water is going to be reduced its area. Okay, so that one we can consider the conversion, but divergent part will be not there in that. Okay, so by using this, continuity equation and Bernoulli's equation, where you can use at the inlet of this nozzle and at the outlet of the nozzle, the discharge we can identify, because we need to find out, finally we need to find out the discharge. So discharge can be calculated by using this concept of venturimeter. So we know that this discharge also we have derived it during the venturimeter. So there we got CD equal, Q equal to CD into area A1 A2 divided by root over of A1 square minus A2 square into root over of 2GH. Okay, so this is the discharge formula for the nozzle meter. Now here we know that the CD equal to the coefficient of discharge, and the value of this coefficient of discharge, so that is used to vary from 0.97 to 0.99. So these are the concept of this nozzle meter or flow meter. As I told you, all these things are there. Now here a few more things are there to explain to you. So just I'll explain here itself. Okay, some applications are there for this. This application of flow nozzle, that is to used, as I told you, it is used to measure the flow rate or discharge of a liquid when it is flowing. Okay, and when the fluid is coming out to the atmosphere, then we can identify or we can measure the rate of flow. Okay, and it used to mostly used to in the suspended solids. Okay, which have the property of settling, some liquids used to there and where used to settle down in that. So in that case also we can use this nozzle meter also. And this nozzle meter also used to where the high pressure and temperature of steam flows. Okay, the pressure and temperature is to very high when the steam is flowing with a high pressure and a high temperature. There also we used to use this concept, and for this also some advantages and disadvantages also there. Okay, if you see this concept, so some advantages I'll tell you that very common advantages are there. Installation is very easy. Okay, installation is easy and cheaper in price. Initial price will be cheaper, so that can be considered the advantages. Okay, and we can say compact. It is very compact. And one more thing, the CD I told you the coefficient of discharge, so that is very high, but also you can say very high coefficient of discharge. So these are some advantages are there. Similarly, some disadvantages also there. Disadvantages again I'll write here. Few disadvantages are there. Okay, here as I told you, cheaper in price, but maintenance will be very high. Okay, the maintenance will be little bit costly. And similarly, the pressure which is recovery will be very low. Pressure recovery is very low for this device. And we can say this is somehow, you know, compared to the orifice meter, it is like, you know, somehow complicated. Okay, orifice meter, if you remember, it is very simple. You know, circular plate is there, orifice plate. Okay, so there we used to find out, you know, what is the rate of flow. So this is comparatively orifice meter. This installation is difficult. Now, if you compare with the Venturi meter, it is easy to installation. So these are the some advantages and disadvantages are there for the nozzle meter. So I hope you understand this working principle of this nozzle meter. Okay, see, for the working principle also very simple. One, pressure need to be decreased, the velocity will be increased here, and the flow pattern or how the flow is coming out from this, okay, that is one matters. And here we used to use the concept of Bernoulli's equation as well as the continuity equation, as I told you. So these are the few things we can remember. So it is easy to identify or to remember these devices. So I hope you understand. If you are having any kind of doubt regarding this, query regarding this, you can give a comment on the comment box. Thank you all.